Welcome back. Let's take a look at vector addition today. Why do we need vector addition? Because some physical quantities are vectors quantities. For example, like force. In this picture shows you a situation where two forces need to be added. Like this doggy here is pulling this rubber band into this direction. And this doggy here also pull a rubber band into the opposite direction. Pulling forces are vector quantities. So at the end of the day, who will get the band depends on how much force that person is exerting, and the movement of this rubber band going to the left or the right depends on the resultant force, and therefore you have to add the forces together. Adding two vectors graphically is easy, and it helps you to see where the resultant vector is going to. So let's say that we have a vector A over here and a vector B over there. We want to add them, and let's call it C. C is equal to A plus B. I always remember this. I'm going to connect the second head to the first tail, and then I'm going to draw from the second tail to the first head. I usually say this, head to tail and draw tail to head. So how is it done exactly? So I'm going to start with the second vector, which is B, right here. And I'm going to connect the tail of the first vector, A, to the head of the second vector. So A is here. I'm going to connect at this point, like that. Then, the resultant vector is going to be drawn from the second tail, B in this case, to the head of the first vector, A. So C is equal to A plus B is this vector, this arrow. Wait, what if I'm confused who comes first? Is it A the second or B the second? Does it matter? Luckily, for vector addition, who comes first or second doesn't matter. The answer is the same if you take A first or B first. Previously, we have seen this. We use B as a second. We start B and then we connect tail of A to the head of B, and then we draw from the tail of B to the head of A, and that's when we get C. Now, if I start with A, I'm going to connect B's tail to A's head, and then I'm going to draw from A's tail to B's head. The resultant vector is identical to when I'm starting with B first. So essentially, if C is equal to A plus B, it will also be equal to B plus A. That is the vector identity. It doesn't matter who starts first. You can take A first and B first for vector addition. Here are some vector identities for vector addition. We already know that A plus B is equal to B plus A. Now the second one that I'm showing you is essentially like this. You can scale A and B first before adding them, or you can add them first before scaling them. If C is scalar, is a number, this side of the equation is that you add A and B first, and then you scale them. You scale the resultant vector. On this side of the equation, you scale them individually first, and then you add them up. If you do this, they will be the same. To enforce your learning, write, comment, or share what you have learned today and hashtag PhysicsLitUp. And subscribe to Physics Lit Up for the next video.